That's nice.
We should explain that.
Okay, so we first wanted to do probability of penalty kicks, but there was like a really small sample space, and you couldn't really, each shooter and each goalie didn't face enough penalties to have a very accurate result. So,
You kind of veered away from that.
It's one of the process.
yeah, we kind of went to a different thing.
Like free kicks and like what affects it and how to improve it. Free kicks is what we kind of like moved into, and like mainly like the physics around what's happening when a ball, because like you can shoot a ball, but like you can put like curves and different spins on it that'll affect it and try to beat the goalie and like do it.
Knuckleballs make it like have topspin, so it drops down like when it's in the air.
There's like no spin.
No,
There's basically
That's
no
not
spin.
spin.
You don't really know where the ball will go.
Yeah.
It's all random.
Yeah. And
The
this,
Magnus effect. It's the observed striking pattern of the spinning ball curving off its principal path, which the principal path would be like kind of like the parabola where it would just fall straight, but it's not a principle like in the way that it's always apparent. It's an accidental phenomenon based on fluid flow, and air is a fluid around an object without a streamlined shape. This means an object that does not reduce air resistance. In our case, this is a standard size 5 soccer ball. One of the types of top spin is top spin, like Charles was saying. When a soccer ball is shot, this means that the ball is spinning in a clockwise rotation. I'm pretty sure this isn't the right one, but another picture shows it where air would be coming this way, the ball is spinning like that. It's kind of the same, but this is due to one effect is that when spinning in air, the velocity on top of the ball, velocity is the speed of motion, this is due to the ball is less than the velocity on top. The velocity on top of the ball is less than the velocity on the bottom of the ball. This is due to the fact that the ball is spinning against the airflow on the top of the ball, while on the bottom it is spinning with the air. Since the air is moving slower on top than on the bottom, pressure is higher on top. This is proved in Bernoulli's principle, that when air velocity decreases, air pressure increases, and vice versa. And in the start of our project, we thought we were going to use Bernoulli's principle to figure this out, but he mainly focused on like like when bullets curve. So, but it kind of has to do with the Magnus effect, but the Magnus effect is more tailored to like objects and sports.
yeah, the Magnus effect is probably seen in every sport. I mean, mostly baseball, because each pitch has Magnus effect, the curves and sliders.
And pros in tennis, they use that a lot to make it drop like close to the net.
Volleyball, all those, golf. Yeah.
A downward force is put on the ball because of this and is propelled to the ground. There are many other forms of spin. One type that is infamous for beating goalies is a knuckleball, like Charles said. When shooting a knuckleball, you actually try to stop the ball from spinning. This causes the ball to have a random path change when in flight. Air flows over stitches and ridges on the ball to create vortices or vortexes. This is when air flows in a spinning pattern around an imaginary axis. This in turn creates a turbulent wake behind the ball. A turbulent wake means the speed and direction of the fluid flow can vary. There's also steady flows where a ball is more, that's for like in a knuckleball it could corkscrew, so it could go in 2 directions because there's many ridges, but when you're doing like a top spin, it'll usually just fall down. That's a steady flow because it's not changing many like speeds and directions.
And the ridges are for the like laces on the baseball. So like when a pitcher throws it, he can like use like where to put his hand on the laces to direct where the ball curves.
This picture is basically just saying air is coming from this way, it curves around the ball, and then it makes the ball spin. So this is just another picture of the Magnus effect. This is the one that you pictured. And
You have a phone with some
Control
guy.
What?
Dude, I copied it before, so just gonna
You can do
you
control
just
click.
like escape it.
It's just
Double click.
Can we go out of the PowerPoint now?
Yes. Yeah.
Whenever you
You can
can.
try double clicking.
lot of videos, so actually there's only 3.
An idea is the source of simple getting.
So back to the inverse exhibit with what?
The ball is spinning in the same direction as the air on the top, but in the opposite direction at the bottom. Because of friction between the air and the ball surface, air is dragged around the top of the ball downwards towards the back, but at the bottom of the ball, the airflow and the ball are opposite directions. The air comes to a screeching halt fairly soon, instead of being deflected upwards. The net result is air is deflected downwards. Due to Newton's third law, the air exerts an equal opposite force on the ball, which is upwards.
So how would sports players take advantage of the Magnus force?
This is like
They make the ball curve through the air by a different amount than that due to gravity alone. So a golfer will strike a golf ball with backspin. That exerts a vertical force, a lift force on the ball that keeps it in the air for a longer time and therefore it travels further.
Mm-hmm.
A tennis player will hit the ball with topspin. That causes the ball to curve down onto the court after it passes the net. A baseball or cricket player will also do that, but in addition, they can make a ball curve about a vertical axis, in which case the ball will either curve to the left or to the right, away from the batter.
Making it much more difficult to hit the ball.
That's the object of the exercise.
I see. So are there any other air effects that we need to be aware of?
There's quite a few actually. There's the buoyant force acting on a balloon, for example, or any object. There's a drag force acting backwards.
So this guy is he's a Brazilian and he retired last year, but he has probably the best free kick in soccer history. It was back in 1997.
So this goes back to
Is that Actually, I'll play.
I'll restart that.
no, it's not very easy.
Mind the language. He spends all his time on the training ground on that. So practically nothing else. Found the perfect velocity and the perfect distance and the perfect angle to shoot it.
And during the last weekend we were supposed to like try that, but Marty fractured his hip, so
We're gonna do it next weekend.
Because that's what we learned. We learned how to curve the ball, like during like the process of making like finding all this information. That's what that's what like our goal was after we kind of scrapped the probability.
you know, in
How are you gonna
theory.
see it?
The video.
Yeah,
when we
hopefully.
finish
Yeah. Marty
Unless we
can't
can't
do
do
it
it.
today.
Yeah.
So that's just the
Yeah.
ball. Okay, so this
The knuckleball.
the knuckleball.
It's probably the hardest shot to do before. Unless you try it outside of foot.
So yeah, this is Ronaldo, and he's really good at the knuckleball. There's gonna be a favorite. So and he's also really good. How do you say that?
Do you mean
Vacuna. It's also Brazilian. So a knuckleball, what's so hard about it? It has no movement. So the goalkeeper can't really tell which way it's gonna curve, so he can dive. Kind of like freezes the goalkeeper for enough time.
Yeah, and you can see the motion of the ball. How it's
You wanna do that? This happens every time. Well, he saves it, but still a pretty thick shot. Yeah, so
The shortcut is obvious.
So if you look at it, how it drops, there's like a spin on it. Well, not a spin. It's slow.
It kind of like has a pause.
Yeah.
Yeah.
I think it is.
And then it's hard for the goalie to find.
That's sweet.
He barely
Like
got that
sometimes people like they just go for curve, but like they'll curve it like out like this is the post. This would be like a post like that. They curve it so it looks like it's gonna go out, and goalies sometimes don't even try to get it, but then it just curves right back in.
Okay, and then in the one with like the older guy, he had, if you noticed how
He had
the
that
recorder had the paper, and earlier in the video, if you want to see it, he demonstrates how when you roll it off like a platform with the spin on the top, how it rolls backwards a little. So we try to So like when you see it rolling, it goes there, and then after it drops off the board, it spins backwards. So you no longer roll it.
Is that like top spin?
Yeah.
And
Oh,
then
there's
Jeremy did this from another video.
yeah, it should work, but it's kind of showing like how air goes through a shape like this and it makes it spin really weird because it's like it kind of wobbles in the air.
So this is in the roll bands. I thought it probably makes sense.
And again, we're gonna make a video, and that's gonna be our other demo.
Yeah.
Yeah.